So, welcome to this final lecture on the problem solving sessions on machine learning. These lectures were designed to solidify your concepts. Today, we will be solving questions on the last two topics that I taught you, agglomerative clustering, and if I remember correctly, it was evaluation of the classical classification models. Okay, so we'll do solve some questions, 5 questions on the same, and then what we'll do is we'll discuss the solutions, and that way you can also know about these things in a better manner. Okay, so let's start with the first question. Before starting, as always, my name is Aditya Agrawal. I'm an MS graduate in computer science from IIT Madras. I was a data scientist long back in Heritage Technologies, Hyderabad, and I hold a BTech in computer science from the Kalinga Institute of Industrial Technology, Bhubaneswar. So, if I go to the first question that is given here, the first question says, um, yeah, so with the help of a confusion matrix, what you can compute, right? With the help of a confusion matrix, what can you compute? So, if you guys remember, right, if you remember the confusion matrix, I taught you in this in the uh, in the lectures. So it's a matrix of if you have a binary classification problem, then it is a matrix of 2 by 2, 2 rows and 2 columns, and here it denotes the actual, like positive and negative, and here it denotes the predicted, like positive and negative. So which means if your actual data says that a particular data point was positive, and your model also predicted it as positive, then it is nothing but true, called true positive. Okay, and if your actual was negative but your model predicted positive, your model falsely predicted that is positive, so it's called a false positive. Okay, and if your model, if actually the data point has positive class and your model predicts negative, so your model has falsely predicted it as negative, so it's a false negative. And if your actual is negative, so actually your prediction is negative, and your data point is negative class and your prediction is also negative, that is called true negative, right? Now they are asking that, with if I just give you this matrix, will you be able to calculate the recall? Will you be able to calculate the precision? Will you be able to calculate the accuracy? Will you be able to calculate the all of the same? So if you see, let's start with accuracy, right? Since we know accuracy very well. So accuracy is like, out of all the predictions I have done, which is if I just add up all the values, because either it will be true positive, true negative, or it will be a false positive, or it will be a false negative. Out of them, how many are actually true? And so true positive denotes how many are actually true, given true, and true negative means how much your model has predicted negative, given that it's actually negative, right? So this is your formula. So accuracy you can calculate. So can you calculate recall as well? If you recall the formula of recall, then it is nothing but number of true positives divided by number of true positives plus number of false negatives. So this is nothing but how much you actually predicted true over what were the total number of predictions, right? So that is also you can calculate. Another thing is called precision, and precision is nothing but, out of all the positives that you have actually predicted, which is true positive plus false positive, how many of them are actually positive, right? So that is your precision. So you can calculate all three of them only using the confusion matrix, and that is why the answer is actually all of the above. Okay, fine. It's taking some time to load. Yeah. So here it says that you are given a false negative value of 5 and the true positive value is 20. What will be the value of recall? So it's very simple. You just have to recall the function, recall the formula of recall. Okay. So what is recall? Recall is nothing but true positive, right? Divided by true positives plus false negative. Okay. So you just have to plug in the value, which is 20 divided by 20 plus 5, which is 4 by 5, which is 80% or 0.8. So C will be your correct answer. Okay. So I hope you all recall the formula for each of the things that I calculated. Make sure you remember them. There can be direct questions like this, and that way you will be able to understand it better. Okay. Fine. Moving on to the next question. In agglomerative hierarchical clustering, what does the algorithm begin with? So, if you recall the agglomerative hierarchical clustering algorithm, it is nothing but a bottom-up clustering algorithm, right? It is a bottom-up clustering algorithm, which means initially what you are assuming that each data point is a single cluster. So, if you have, let's say, n data points, x1 to xn, let's say till xn, all of them belong to a single cluster, and then you take two of the points, make them a cluster which are closest to each other. Let's say you're taking two of the points, then you take two of the next closest points, make them a cluster, then take the two of the next points, make them a cluster, and like this, your algorithm proceeds till you reach the root node, which contains all your data points. So this is a bottom-up clustering algorithm, and agglomerative hierarchical clustering is one of the examples of a bottom-up clustering algorithm, and in which each data point is first assumed to be a separate cluster. Okay, and if it was just hierarchical clustering algorithm, then a top-down clustering algorithm will consider all data points as a single cluster. Okay, and then you try to break them into separate clusters depending on the distance, which is a distance metric that you use. Okay, predefined number of clusters, option C says. So option C says, does it mean a predefined number of clusters? So if you recall, when you were learning k-means clustering, you have to fix the value of k, which is the number of centroids or number of clusters. And here you don't have to, I don't have to actually do that. That is the advantage of using hierarchical clustering over k-means clustering. So you don't have to set any predefined number of clusters. It will actually find it for you. And option D says, what does the algorithm begin with? The optimal number of clusters. Again, if you can find the optimal number of clusters before running the algorithm, then there is no point to even have the algorithm in the first place. If you have the optimal number of clusters, then just find the use a k-means, and then you will get the answer to the. You'll just be able to find the optimal cluster in one iteration. Okay, so that is why in hierarchical clustering algorithms, it is typically done when you don't assume the number of clusters beforehand. But here is one thing that you should remember that, so what is that? I told you the advantage, right? Then you might ask, okay, then why would I use k-means? Okay. So the other issue with k-means clustering algorithm is the problem of k-means clustering algorithm is that um, sorry, the problem of hierarchical clustering algorithm is that it is computationally intensive. It is not. It is not. It is computationally intensive. So you have to calculate the distance across each point. So you have to do the merge process as well. So you have to merge two or more data points to form a single cluster, or maybe separate out if you are using a top-down clustering algorithm. That is computationally intensive compared to just computing the distances from a centroid across each point, and then taking an average across all the points that you find, redefining the centroid. Like if you remember the top-down clustering algorithm that we have discussed, it is much more simpler when you do, sorry, not top-down, in the k-means clustering. And so that's what I'm saying. So it's much more simpler if you are actually doing a k-means clustering algorithm, right? So k-means clustering algorithm is less computational intensive, while hierarchical clustering has the beautiful thing that you do not have to assume any particular set of clusters beforehand. It will actually find it for you. Okay. The next question is, okay, what is a dendrogram? So a diagram that represents a tree structure of hierarchical clustering, or is a diagram that represents the optimal number of clusters. A diagram that represents the density of a cluster is a diagram that represents the distance between the clusters. So option D is definitely not correct, because a dendrogram, if you remember, it's actually the diagram that represents a tree structure of a hierarchical clustering, right? If you remember, I had, let's say, 6 points x1, x2, x3, x4, x5, let's say 5 points only. You first merge this two, then let's say you merge this two, then maybe you merge this two, then you merge this two. Okay, and this is your final. So this, you're saying this belongs to one cluster, which is maybe the first set of data points that you're seeing very close to each other. Then you find this cluster. Then you see that, oh, then what I can do is I can also take x3 here, right? That can form another cluster. So like that. So the endogram actually represents the tree structure of hierarchical clustering, and the diagram does not represent the optimal number of clusters. There is an algorithm that you can use to calculate. You can just draw a vertical line which passes through each point, and you can see here that whichever meets here. So this is one cluster, this is one cluster, and this is one cluster, right? Which you draw a parallel line, and okay. So maybe I should teach this, because maybe I don't know whether I've taught you this or not. So all of you have drawn the dendrogram, I guess. Dendrogram is drawn and that part is done. So I'm not going to that. Let's say this is the final dendrogram you find, and let's say you want to find the optimal number of clusters, right? So what I will tell you is, what you need to do here is, let's say you draw a vertical line like this. Okay. Okay. Now you see which points are intersecting with the cluster. So this is one, this is one, this is one. So if you look at the first intersection, it consists of 2 points, x1 and x2. So that is one cluster. Okay. Then you look at this point, the next point, which is a single cluster containing x3. Then you look at this point, contains two data points, x4, x5. Okay. So maybe that you can call as an optimal number of clusters, or what you can do is, I can say, hey, what we can do is, instead of drawing the line here, if I can draw the line here, right? So if I draw the line here, it intersects in 2 points, right? And the first point contains the data points x1, x2, x3. So that's one cluster now. And then the second contains x4, x5. So that is the other approach that you can take here to answer this question. So optimal number of clusters you need to find out, right? If you need two clusters, you need three clusters, you want to cluster into, let's say if I draw a line here, for example. So let's say if I just omit this all and I draw a line here, let's say. Okay, how many clusters do you think you have? So it consists of 5 data points, each of them being a single cluster. Maybe that is not the optimal answer for you. So you will say that, hey, what I can do is I can go a bit up. So I can consider the other line or the other line. So so the dendrogram helps you to do that, right? And the dendrogram helps you to calculate the clusters once you have done the calculation. Okay, so this hierarchical tree structure that is present here is called the dendrogram. So option A is the correct answer to this question. Okay, a diagram that represents a density of clusters. Okay, fine. I mean, see this diagram. Can you tell me the density of a cluster? Maybe not. Maybe first you have to define what is the density of a cluster, right? Like it's more like um, how close are 2 points to each other, right? So this is one cluster, you can say. Maybe I can make x3 here and call this a cluster. Okay, sorry guys. Think it got zoomed in. Okay, and maybe you can call this as a cluster. Okay, I mean, so there's none. Dendrogram can't actually tell you this. It just tells you the tree structure of the hierarchical clustering, and then after that you have to go ahead and find out the optimal number of clusters by looking at the diagram. Okay. Fine. Moving on to the last question in this series. Or maybe what I will do is I will also discuss one more question after this, okay? Just a bonus. So consider the two statements. In single linkage clustering, we consider the minimum distance between two data points in two clusters. In complete linkage, we consider the maximum distance between two data points in two clusters. So these I don't have to explain it much, right? Because these are direct from the definition. In a single linkage clustering algorithm, you consider that's actually the definition. You will consider the minimum across two distance between two data points in the two clusters, while in complete linkage, you will consider the maximum distance between two data points in the two clusters, right? So that is actually, and they are saying which of them is incorrect. Neither S1 nor S2 is incorrect because both of them are actually correct statement. They are just the definition of the single linkage and the complete linkage. So we since have some time, what I can do is I can just I can just give you a simple problem regarding confusion matrices. Okay, so I won't give you any theoretical things. Okay, theoretical or anything theory here. I didn't discuss ROC curves and all that today because again, maybe I don't see that importance of ROC curves in the exam. Maybe they can give one question. I don't know, but since this is the first time gate DA is happening, you never know you don't know what will be asked. But what I will do is let's talk about some conceptual things. Okay, maybe I've discussed that in the class, but it's good to recall as well. So consider a confusion matrix, right? So consider this confusion matrix. Here denotes the true positive, right? Here denotes the false positive. Here denotes the true negative, and here it denotes the false negative. Okay. Let us say that I have told you, let's say you are working on a data science company. I'm your manager, and you built a classification model, binary classification model. Let's say you work in a healthcare company and you have a cancer data set. Okay, you have a cancer data set. Okay, so which means positive denotes that no cancer. Okay? Okay. I don't want to be sadist by saying positive means cancer. Sorry about that. Positive means no cancer. Negative means the person has cancer. Okay. So true positive would mean that actually the person had cancer and your model predicted he has cancer. All good. True negative means, sorry, positive means the true person did not have cancer. Actually, the person did not have cancer. Your model also predicted that the person does not have cancer. So that's true positive. True negative means your data content sets your data says that the person has cancer, and sadly your model is also saying that you are having cancer. Okay, and let's say this, and so false positive would mean that actually you have cancer, but your model is saying you don't have cancer. Okay, and false negative. Okay, so sorry. False positive means you have cancer, you actually have cancer, but your model is saying you don't have cancer. And false negative means you actually do not have cancer, but your model predicts you have cancer. Hmm. If I am your manager and I give you one chance, okay, I tell you either you minimize the false positive or you minimize the false negative. Which one of them will you select? So will you try to minimize your false positive or will you try to minimize your false negative? So what do you answer? What would you prefer? Let's say, let me give you a hint. Okay, maybe this is very abstract way of saying it. Let's say you want to minimize, okay, repeated hospital visit. So let's say the company that you work in has a hospital as a client, and hospital has said said you very clearly, see, we rate our doctors in the way that if a person comes back again, that is considered a negative point, which means if once a patient comes in, I give him some medicine, give him some treatment, give him some diagnosis. Later on, I don't want him to come again and say, "Oh, I had fever, now I got typhoid." Right? So that is a negative point for the doctor. Okay. So you want to minimize a person visiting the hospital repeatedly. Okay, so what thing will you try to minimize now? Will you try to minimize your false positives or will you try to minimize your false negative? So understand the domain. Okay, the domain is, what does false positive mean here? False positive would mean as you actually have cancer, hmm, and then your model says you don't have cancer. Okay, so it's more like, let's say that hospital does not have a doctor, it only believes in the confusion matrix. You go in, you punch in your data, and out comes a prediction that, hey, you have cancer or you don't have cancer. And your model predicted you don't have cancer. Okay, you go back to your home, tell your father, hey, my hospital said I don't have cancer. Tell your parents, so yeah, you party all night. Later on, you find out that, oh, actually, I had cancer because now I'm getting some symptoms of cancer. So you will again go to the hospital. So that is what you want to minimize, right? You want to minimize your repeated hospital. That's actually one of the ways by which hospitals try to work in this sense. I mean, no hospital would, hospitals are not evil that they will want you to come back again and again. They are there to do their job, which is to cure you, not to make money, right? So, again, so that's why you will, in this scenario, considering this case, you would try to maybe minimize your false positives, because false negative is more like um, you actually do not have cancer, which is your actual is positive, but model predicted, oh, sorry, you have cancer, right? So now you can argue that the medicines that you take might actually cause some other illness as well. Again, might be okay, but that is also a possibility. It's not a necessity, right? So it could be that your hospital said, hey, do one thing, eat more fruits, exercise regularly, eat healthy, sleep on time, right? And those are habits that you can also have if you don't have cancer, if you even don't have a doubt of having cancer, right? So that's just an example, okay? So now you might be thinking that, hey, then when can I minimize my false negatives, right? So let me talk about a very real life scenario. Okay. Let's say, okay, I'm not discussing any businesses here with you. Let's say there are two businesses, X and Y. Okay. Let's say Y is a popular um, soft drink company. They are very good in making soft drinks. Okay. I don't want to name any company here, but there is a very good soft drink company. This soft drink company knows how to make that drink. Okay. He doesn't know packaging. What they do is they go to another company to get their bottle. So this is a glass bottle manufacturer. Okay, he's a glass bottle manufacturer. So what X does, X specializes in making different type of glass bottles. They can make if you see any popular cold drink, then soft drink, then you'll see it's in a glass bottle, right? So they make very good glass bottles. So Y goes to X, purchases some set of glass bottles, and Y then sells it to the market, right? Now, what usually sometimes happen is, let's say Y gave an order of 100 bottles for X, saying, hey, give me 100 bottles. And X said, oh, sure, why not? Take 100 bottles, deal done. Okay. Now, Y will say that, let's say when it was when it was in a truck, right? When it was going from X to Y, 10 bottles broke down. 10 bottles broke. So Y actually got 90 bottles. Now, how much did Y paid for? Y paid for 100 bottles. How much did Y got actually? He got 90 bottles. Correct? So for the 10 bottles, why will Y pay, right? Those are crushed, those are gone, those are broken, right? Those are broken. So Y will say X, hey, actually what happened is you gave us 100 bottles. I asked for 100, but 10 broke, right? X will say, oh, sorry. Then what you can do is I can refund you the price for 10 bottles, right? I'll refund you the price for 10 bottles, okay? So So what happened is, so 10 bottles broke, right? And X said, hey, what I can do is I can give you the refund for 10 bottles, right? So Y said, okay, fine, done. But Y is clever sometimes. Y, let's say no bottles broke. X is not, X is based in some factory in very far away, and X has sent those bottles, and Y, just to gain some more profit, bluffing, is bluffing, right? So whether Y's claim is valid or not can also be modeled as a problem. And this is one of the problems where I worked when I was working as a data scientist in Hiratius, right? We are a fintech company. We were working on one of these problems. So over here, positive means, let's say, that the claim is actually valid. Okay. And negative means that claim is invalid. Okay. Now, how do you make true data? Maybe the company, when they claim a deduction, the X can send some person there and say, hey, go and check what happened. And then they found out that, oh, they are just bluffing. Then that will lose the trust also, and they will be flagged as claim is invalid and all that, right? So over here, if you see, false positives are like, actually the claim is invalid, hmm, but your model is saying that, hey, that whatever Y is saying is actually true. Okay? Y is saying that, yeah, I mean, this is the problematic part, right? So now it depends on the perspective. So okay, let me just reframe this because this is sounding a bit confusing. Positive would mean that Y is true, right? And sorry. Okay, fine. See, what would happen here is we are selling the model to X because X is the seller. When X sells it to Y, X will say that, hey, is Y a trustable customer? Has Y previously taken from other companies like W or Z or A or B or C? And have they claimed deduction? And are those deduction valid or not? So X would mean that um, X has to pay and X does not have to pay. Negative means, right? So false positive would mean that actually X does not have to pay, but your model says that X has to pay. That means your Y is actually now profiting here. That is a false deduction claim, right? It's a false deduction. So again, and false negative, what would it mean? It would mean that actually X does not have to pay, right? Sorry, actually X has to pay, right? But negative, but your model says that X does not have to pay. Actually, X has to pay. There is a problem. There is an issue, right? But your model is saying that, oh, X does not have to pay, right? This can lead to disputes between X and Y. So this is something that is counterintuitive also, right? Because if Y is getting the goods and Y is saying that, hey, it's broken, come on, give me the money. X is saying, no, my model is saying that I do not have to pay, right? Which is incorrect in this scenario. And so we can say here that your false negative should be minimized. So what I'm trying to convey here is that actually here false positives should also be minimized, but false negatives are more thing that actually defines your how good your model is in this scenario, right? So it depends on the context, which context in which you want to minimize or maximize your false positives or false negatives, right? So that is what I had to talk about. You can talk a lot about classification models by just looking at the confusion matrix. So this is what I wanted to say in this lecture. With this, I think I have done with the problem solving lectures on this topic, on the topics of ML that I've covered. Um, With this, maybe I will wrap up this lectures. And again, I've solved more questions as well if you look at the lecture series, right? So go ahead and look at the lecture series and solve those questions there as well. Learn the concepts that I have taught. Um, Again, this was a short course, so we try to cover as much as possible in the given amount of time so that you also don't get bogged down. Right. So that's all I wanted to talk about in this lecture. Again, if you want to enroll in our courses, go to www.iitiansgateclasses.com. You can mail us at info@iitiansgateclasses.com. You can call us on this number that is given in the slide below. And with this, I would like to wrap up my lecture here. Thank you for listening and all the best for the exam.